Can you please confirm me once whether I'm audible or not? You can write in the chat box. Okay, so let's wait for 1 or 2 more minutes and then we shall start today's session. Um, okay, let's start discussion and by the time let others join. So, good evening all. So, today is the ninth week discussion session of the operation and planning of power distribution systems, and we have covered uh, mostly the operations part, how the power systems operations or the distribution system operations is mostly concerned, and we have solved many numerical problems related to the types of modules, which the modules that were discussed, so relevant problems have been discussed all throughout, and we have tried to solve the assignment questions. So similarly, today also we'll try to do the same. So already as we came to know from the weeks, from these weeks, these two lectures that were being delivered in this week. So mostly it was in the economic side or economic aspects of the distribution system and the planning studies. So how distribution system planning works. So here many things were covered, and out of which the the cost. So there were how the systems in the distribution system planning. So let me just in distribution system planning, what we are trying to do, we are trying to minimize, maximize some objective functions, and accordingly we will try to obtain the best possible system planning so that the distribution system gets the best possible way with the minimized cost. The cost should be minimized. So as we are prioritizing cost here, so there are two segments, which is fixed cost, and the other part is the variable cost. So in the fixed cost segment, there are when a substation needs to be established. Okay, so substation cost, substation cost can be taken into granted. The inspection cost needs to be taken into granted. So the equipments, first set of equipments that needs to be considered, like each and every year testing needs to be done in the substation. So testing cost needs to be incorporated. Various maintenance cost. And coming to the variable cost, so most important is the losses. Okay. So when we have the losses, so how is losses uh, dependent? So when the load is continually changing, we will observe the load to change continually, right? In the distribution side, load changes. So with the load changes being encountered, the losses also try to deviate from the same set of values. So losses are variable parts. Okay, the losses will tend to be the part of the variable cost. So based on the loads, the losses will be varying. So and that will lead to cost associated to it. And for these kind of changes, mostly some fixed cost, the part that were discussed, that is the time worth of money. So when we discuss, so time worth of money, this part has been discussed thoroughly in the week's content. So as we can understand that suppose we are to buy something or we are to purchase something in the next or in the upcoming year, so accordingly how much money do we need to have in the current point of time. So based on that cost, we need to at least have that much amount which has to be kept aside to you can say to establish a substation in some point of time, which is maybe 1 year, 2 years of time. So these things are being discussed. Okay. So next comes the present worth analysis. Present worth analysis. So from the present worth analysis, we can based on the P is the present worth factor. So based on the present worth factor, we can we can calculate that how much amount we need to have now so as to purchase something in the upcoming years. Okay. So all these things were discussed, and levelized cost were being discussed, that things needs to be compared, right? So when things needs to be compared, there has to be a certain scale based on which we can understand that yes, these things are comparable, and this, but that means the unit should be same. So there comes the uh, utility of levelized costs, and all these things are detailed. And this was mostly from the first, and some examples were being presented by professor, yes. So coming to the other part where, so coming to the next part where mostly the distribution system planning studies were being detailed, from optimization functions, how the optimization functions are framed, and what forms the basis of this optimization function, what thing needs to be taken into consideration, what are the constraints that needs to be taken, constraints, and based on the constraints, what are the types of constraints that needs to be taken for the distribution system planning, and how these constraints are, the type of these constraints can be both integer type, mixed type, means integer as well as fractional parts also. So based on whether there will be a line with between the 2 points, so that will be 1 or 0, so that can be an integer only answer. So considering all these various kinds of constraints, like the line limit, line overload limit, line power carrying capability limit, all these things taken into consideration, the distribution system planning needs to be done. And since this planning is one time procedure, means yes, they can be, planning can be done multiple times, but at least when a substation is established, so it is assumed that the substation would work in the same condition, not in the same condition, means the loads will be changing, but at least it should work for the next 25 to 30 years. So accordingly, the planning needs to be done where the load growth should also be taken into consideration. Okay, and the current loading scenario is to be taken into consideration, because the the load will expand on a certain means per year, the load will definitely expand. So accordingly, the expansion that needs to be taken into consideration right now, considering the future scope. So that all these things needs to be taken into the system or in the optimization problem, considering that the voltage profiles should be within the specified limits, and some loss loss you can say loss minimization. Loss minimization needs to be taken into consideration. Voltage profile should voltage profile should be maintained within the specified limits, and future scope of load expansion. Future scope of load expansion. So all these things needs to be taken into the problem, and based on that, the distribution system planning problem, uh, mainly various solution strategies are there, which can be deterministic, which can be meta-heuristic, and the optimization problem needs to be framed based on various constraints, and accordingly the constraints can be it will be multi-objective, definitely, because there are numerous constraints that needs to be taken into consideration. In some cases, the deterministic approaches can lead to results which may be time consuming when number of constraints are high. But in case of the Materialistic approaches, systems may converge at times faster, although the optimality will not be ensured, that can't be ensured priorly that each and every time the optimal value would come to the same. Yes, it will be near to the optimal value, but it can't be ensured that it will always come to that exact point. So these were the basic discussion, and accordingly one problem was taken up. It's not a problem, but the objective or the problem formulation has been taken up, and accordingly various solution strategies were proposed. So that was the entire week's overview. So if you have any queries, we can deal with that first, and we have the questions, so we can start solving the assignment questions. So, so if you don't have any questions, so we can start the assignments. Okay. So this is the question: a substation expansion needs this amount of money after 5 years of now. So how much money the utility should have right now to do the expansion? Assume discount factor as 10%. So this is the question. Please try to solve. These are the answers. Yes, these are the options, not the answers. So please solve it and write it in the chat box. So what you can see here is that Okay, so this is the first assignment question that we were discussing. So you can see the question on the screen and try to solve, write the answer in the chat box. And parallelly, I'm also starting to solve the question. Otherwise, we have other questions too. So, and if you somebody has found the answers, you can write in the chat. So here discount factor is 10% given, right? So when discount factor is given, so present, what will be present worth factor? P. P is a function of D, right? Discount factor. So here it is 1 by 1 plus 0.1, 10%. So 1 by 1.1. Value that it is 0.91. 0.909. So when present worth is given, present worth factor we have obtained, and we have to calculate the utility, how much money it should have right now. So, and it will be needing around, what is this is 50 lakhs, if I'm not wrong. Yes, 50 lakhs, yes, 5 million, yes, 50 lakhs. So 50 lakhs it should have on the next year. So now the amount should be amount, the amount of money you can say, the utility needs to have today is, suppose M is the money, so and T is the present worth factor. So 2 to the power T, T is the number of years, T is the number of years, M is the money. Let's say this is M. So we just to 0.9, 0.91. Oh, sorry, this is 5 years, right? Five, this will be 5. So 50, okay, 5 crore. There's 10 more. This will be, so 1, 2, 3, 6. Yes, 3, 1, And it's coming approximately this, not exactly. The answer is given C. Value is coming 3103054. So it's approximately, answer is, right answer is given C. So this is the answer. So can say the answer is C. Correct answer is C. Okay. Is there any doubt in this question? Otherwise, we can move on to the next. So this is the next question. The present worth of a distribution network planning is 10 lakhs for a planning period of 5 years. What will be the levelized cost for this planning? Assume discount factor 10%. So we have to calculate the levelized cost. Okay. You have the direct formula. You can just place these values, put these values in the formula and get the results and match with the options. So you have the direct formula, just 1 plus 1 plus d to the power n this entire thing. This is the discount rate. So here n is equal to 5, is equal to, so just place these values and also B. Yes, B is the correct. B is the correct answer. Okay, so now we have some questions. We have numericals later on. Some numericals are there, but for the time being, some questions are. This is the question. Present worth factor needs to be multiplied with future non-recurring cost, future recurring cost, both or none. The present worth factor. So based on the numericals that we have solved, present worth factor needs to be multiplied with future non-recurring cost, future recurring cost, both or none. So present worth factor from the example that sir has shown in his lectures also. So this has been considered with both the non-recurring as well as future recurring. So the answer will be both. That present worth factor has been taken with the consideration for both of them. Okay. So the answer will be both. So so this is the question. So static planning problem of power distribution systems is one-step planning without consideration of load growth, multi-step planning with consideration of load growth, contingency planning, and all of these. Yes. So static planning is one-step planning without consideration of load growth. Options are same. These options are also same as the previous ones only. Okay. This question is same for just this is the dynamic problem. So What changes do we need to incorporate here? Yes, we understand. So it's the multi-step problem. So here, in the dynamic problem, we consider the load growth, whereas in the static problem, without consideration of load growth. So these are the keywords to take these things into account here. So, so meta-heuristic optimization algorithm works with calculus-based mathematical rules, nature-inspired meta-heuristic rules, iterative updating of randomly generated solutions, and non-iterative direct solution approach. So consider this question as MSQ. So there are multiple options correct. So B is one of the answers. C is another option. Yes. So the question is the advantages of meta-heuristic optimization are, so you have to highlight the advantages, right? These can be used in solving nonlinear problems. So these can be used in solving problems with non-differentiable objective functions. Then these can be used to solve problems with large number of variables and all of these. So given answer D, right?
Yes, sir.
Yes, yes. D is the correct answer. Yes, these are, as Sarah has also discussed in the lecture slides itself. Problems can be nonlinear, problems can be non-differentiable, problems can be of large dimension, large number of variables, large number of constraints. In all these cases, the materialistic algorithms do work fine. Whereas in the deterministic approaches, sometimes the convergence, to attain the convergence becomes very tough. So this question is on the based on the limitation of the materialistic optimization, right? So previous one was the advantages, which is on the limitation. So so they cannot always provide global optimal solution. They sometimes provide only local optimal solution. The execution time is very long, and all of these. D is not correct here. Yes, they cannot always provide global optimal solution. So yes, so I forgot to mention. This is MSQ. Sorry. Yes, they cannot provide always global optimal solution. This is also correct, and they sometimes provide only local optimal solutions. The execution time is very long. It's not the case for the materialistic optimization, but the optimal solution that we attain at every time. is not the best possible, or we can say global optimal at each and every point of time. That's the difference. So, execution time is better, it's faster than the deterministic approaches when the constraints are very high. And that's the practical case. When the constraints will be very high in case of the practical distribution system planning. So yes, A and B are the correct answers. So this is the question: which of the following decision variable of the distribution system planning problem is integer in nature? Determination of optimal substation size, determination of optimal feeder routes, determination of optimal line conductor size, and all of these. E and C. So determination of optimal line of our line conductor size, optimal substation size. So isn't determination of optimal feeder routes also a decision variable with integer values? Because as sir has shown in his lecture also, this is the ith and jth feeder. So if there is a line, possibility of line connecting between these two of these nodes, ith and jth node, that is also one or zero, much integer value, line connection. It's not about the dimension or the, it's just the way that whether the line should be connected or not. So that will also be an integer. value. So the correct answer in this case is all these three. Okay. So all these three are correct. All of these. We have the optimal substation size, feeder routes, as well as the line conductor size. So three of these comes under the planning where the decision variable is integer in nature. Yes or no, one or zero. So which one of the following is not a meta-heuristic optimization approach? Genetic algorithm, you can see GA, ESO, DP, dynamic programming. Yes, she is the correct. Yes, she is the correct. These two are GA and PSO are meta-heuristic approaches. Okay, so moving on to the next set of questions. This is question. No, so utility needs, this is 18 lakhs, right? This is 18 lakhs. Right now, to do the expansion of a substation, how much money will be needed 7 years later to do the same expansion? So assume the discount rate is 9%. Please try to solve similar type of questions. So first try to identify whether the amount would increase or decrease. Any answers? So this question is just a reversal of the first question that we have discussed. So here the amount is 18 lakhs right now. That is to be required to do a expansion of substation. Okay. So the amount of money which is required 7 years later or 7 years from now. So we can consider let the amount be rupees Q. Just normal critical problem. Yes, B. Yes, B is the right answer. Yes, B is the right answer. So if we consider this amount to be Q at this point of time, so here 1,80,000, sorry, 18 lakhs. Sorry. So 18 lakh should be from, so it is Q and this is P to the power T. So Q, let the Q remain as Q and P in the form of discount rate we need to consider. So 1 by 1 plus D and this entire thing will come under this T. So Q into 1 by 1 point, the discount rate is 9, so 0.9, 1.09 to the power 7. So Q will be, this is the, yes, B is the right answer. So let's move on to question 12. So distribution company has two available strategies to do network reinforcements. Okay. Strategy A involves investing now in network reinforcements, and strategy B involves spending a fixed amount each year over a few years in future. If the company can spend rupees 10 lakhs right now using strategy A, what constant amount should the company invest every year to achieve the target in 5 years, assuming the present work factor as 0.9. So directly present work factor is given. Please go through the question. So try to solve it. Two available strategies. So here it is strategy A. So A means this one. So you need to see first what constant amount should the company invest every year to achieve the target in 5 years, assuming the present worth factor as 0.9. So question is what constant amount should the company invest every year? So if you can see just this amount that is required is 10 lakhs, 10 lakhs, and this amount is more than 10 lakhs, and the target has to be achieved in 5 years. So the answer from the choice itself, you can understand that it's incorrect because it's more than 1 point, sorry, 16 lakhs, I guess this one. Yes, 16.9 lakhs, 93 total. So this is incorrect. Please. The amount should be lesser.
Yeah, this value, the 10 lakh value minus this one, that difference divided by 5, but that option is not here, I think. Is it that
Okay.
way to solve?
Okay, let me solve. Let me solve. So you can see the point. So as it can be understood that so we need to find out the fixed value, right? So fixed amount needs determined which should be invested, should be invested per year considering the associated present worth value, present worth factor, present worth factor. So as we can see, so per year the worth factor will remain same, but when the worth factor to the power 1, to the power 2, to the power 3, so up to 5, when this value or this factor square, zero point 0.9 square, zero point 0.9 cube, so this value will change the amount. So what we need to see is that this 10 lakh rupees is fixed. So we need to equate this 10 lakh to, so we have 5 years equals to 1 to 5, and the x value, or we can say the fixed amount. So let's suppose this fixed amount is q. Let's say the fixed amount is q. So fixed amount into, and the present worth factor, let it be p. So p to the power t. So now if we just equate this one, so q with p value zero point 0.9 to the power 1 plus q into zero point 0.9 square plus q into zero point 0.9 cube plus q into zero point 0.9 to the power 4 and q into zero point 0.9 to the power 5. These we need to equate. So just check. So the first one will be zero point 0.9 cube, then it will be 0.81 cube, and 729 plus 0.6561 plus 59, just add this 1.661 plus 729 plus 3.686 cube. So so 3 to 6.9, then write it 7. So option B is correct. I think you have understood, right? Is it clear?
Yes, sir.
So this
Is
amount,
the formula this sigma I equal to 1 to 5 is a generalized formula?
no, not generalized, but here it is 5 years given, na? So we can just place anything. Means if it question gives 7 years, so we'll have to just place it for 7.
Okay, okay, sir. Okay.
So this is it. This is it. So moving on to the next question. So this is a bit lengthy question. So question number 30. So the a utility estimates that the distribution system should be reinforced within a year, considering the expected increase in power in demand. However, contractor provides the utility with two options for network reinforcement, either to make network reinforcements now or a year later. If the reinforcement is to be done now, the contractor demands rupees 90,000, and if the reinforcement is done a year later, the contractor demands 1 lakh at the end of the year. So consider that the utility can pay in both options and does not get any returns if it chooses network reinforcement earlier. Which of the following is a suitable decision for the utility? These are the options. If the present worth factor is 0.88, is it better to do the network reinforcement now than a year later? If the present worth factor is 0.88, is it better to do the network reinforcement a year later than now? If the discount rate is 10%, it is better to do the network reinforcement a year later than now. And if the discount rate is 10%, is it better to do the network reinforcement uh, now than a year later? Now than a year later, yes. So these are the options. So you just to check the cases. Okay. So, so let's do one thing. Let's try to solve. Okay. So from there, so from the question, some points need to be highlighted. So the contractor demands 90,000 if the work has to be done now, and he demands 1 lakh, 1 lakh when the work can be done a year later. Okay. So these two are the options. So so first point that can be taken into consideration is that present work. So if work is done now, then it will cost 90,000. So present work proportion. So it's 90,000 divided by 1 lakh. So it will be zero point 0.9. So amount that will be expend the amount that is required to be uh, given to the contractor at this point of time. So if we take the ratio, it is zero point 0.9 from now and to the year later. Okay. So so based on this, so we can calculate or compute the discount rate. So what is the discount rate? So discount rate will be, this is 1 minus P by P. So, so rate will be 1 minus P means zero point 0.9, sorry, zero point 0.1 by zero point 0.9, zero point 0.1 by zero point 0.9. So that will be point recurring. So if we convert it to percentage, it will become 11.11%. And considering the cases, so present work factor, if it is 0.88, it is better to do the year reinforcement now than a year later. This is one option, and the present work factor is 0.8. It is better to do the reinforcement a year later than now. So this will be now. This is now first one. This is later for same condition of present work factor to be 0.88. So what we can check is that we can uh, see the present work factor. If the present work factor is 0.88, then this present work factor will lead to a discount rate of how much value? Just check, 1 minus P by P. So 1 minus 0.88, that means 0.12 divided by 0.88. So that will lead to 0.12 divided by 0.88. 0.1363 means 0.1363 or 13.63%. So based on this value, the present worth of rupees 1 lakh spent a year later. So if we say that 1 lakh amount will be uh, spent a year later, the amount that will be corresponding now is that the person should be possessing right now will be 1 lakh into 0.88. Okay, so that will correspond to 88,000. So if the person have to, you can say present worth for 1 lakh spent 1 year later is equal to 88,000. So we can clearly understand if we have 88,000 right now, then we can use that same value of 1 lakh 1 year later. Whereas if we are to do that work right now, we'll have to spend 90,000. So 2,000 rupees we can save, because if we are to do that same thing right now, we'll have to pay 90,000 at this point of time. But whereas if we have 88,000 right now, that same amount would correspond to 1 lakh 1 year later, and we can pay that person 1 year later, or contractor 1 year later, the same amount of 1 lakh. So I think it's clear that we can have a savings here. So we would prefer to do it 1 year later than now. Is it okay? This is the amount that the person should have right now. So both of them correspond to 1 lakh next year. So why to have much? If we are to spend it right now, then one will be 90,000, other will be 88,000. From 88,000, you can't do the same amount of work, same work. So for that, you will have to pay 2,000 rupees more. So similarly, it can also be observed here that if the present worth factor, so present worth factor is if the discount rate is 10%. So when if the discount rates coming to the next part, here we'll have to check the other options too for 10% discount rate. So if the discount rate is 10%, so net uh, or present worth. So present worth uh, for discount rate of 10%. So if discount rate is 10%, so present worth will be 2. So so this is the amount 90,909. So If the discount rate is 10%, then which is more preferable? If discount rate is 10%, to have 1 lakh rupees 1 year later, you will have to have rupees 90909 now. This is required now. So here there is an increment of 909 rupees more that you need to have, whereas in the first two cases where the net worth is 0.88, present worth factor is 0.88, there you have a 2000 rupees reduction. So this is 2000 rupees. There is a reduction in 2000 rupees if you are to do that work now. That is 90,000 you need to pay right now, whereas if you do that work 1 year later, you need to have rupees 88,000 right now. So this is profitable from the perspective of the substation in charge maybe. And whereas in the second case, this if the discount rate is 10%, as we can see for the next two cases, means C and D, where these two are same, these two factor is same. This one is later and this is now. Okay. So what we can observe is that we are to have rupees 909 more. This unit is in rupees, and this is also in rupees. This rupees 909 you need to have more right now, so that you are to pay the contractor 1 lakh rupees with the discount rate of 10%. So better it will be better that you pay that person 90,000 right now and do that same amount of work, so that a 909 rupees reduction you can have. So both these two options are correct. So here you get a profit of 909 rupees if you do the work now, whereas in this case if you do the work later, means 1 year later, you get a profit of rupees 2000. So both the options, this is corresponding, or this is corresponding to option B. So this is giving option B as the correct one, and this is giving option D as the correct one. So both options B and D are correct. So D are correct. So this is for the D part. So this is corresponding to D and this is corresponding to B. First part is for B, second part is for D. Is it okay? Have I made made it clear? So if you have any doubt, you can. Is it clear from my part? Okay. So we have the next question. This question. So this is also same type of question. We have already solved this type of question. So the distribution network requires, this is corresponding to 15 lakh of network reinforcement if the planning process is initiated 5 years later. Considering the present work factor 0.88, so what will be the levelized cost of the planning horizon of 5 years? So first try to identify which answers should be straight away rejected and then start solving this. So this amount is required 5 years later. So amount which is required right now. So if we say the amount to be Q, which is required right now, then it will be 15 lakhs divided by, which is the net present work factor is given 0.88. So 0.88 to the power, sorry. Will be multiplied. So it will be 79798. So this is the amount which is required right now. And for calculating the levelized cost, we need to know the discount rate and how to calculate discount rate from the present worth factor given. So you will have to just place this. So it will be 0.12 divided by 0.88. So this value we have calculated. This is 0.1363. So 1363 is the discount rate. So just calculate the levelized cost. Directly apply the formula. Levelized cost is equal to 1 plus d to the power n into d 1 plus d to the power 2 minus 1 into q. So just place these values. So 1.1363 to the power 5 into 0.1363 divided by 1.1363 to the power 5 minus 1 into q. So what is q here? Q is 791 791,598. So just check what will be the answer. I have the final answer. 363 to the power 5 into 1.1362 divided by 1.1363 5 answer is coming 28, sorry, 22853. So this is the answer. So it's nearing the C. So some small roundup errors incorporated, but the answer is C. So the answer that we have obtained here, it's nearing this value. Option C, 228588. So 50 rupees somehow mismatch happened. So is it fine? So these are MCQ type questions. So please do it fast so that we can wrap up. So which of the following is correct about the cost evaluation involving embedded cost, marginal cost, and incremental cost? So this is MSQ. So please see to the options, and multiple options are correct. So you can just write it in the chat box. So which is marginal cost? So embedded cost involves all the initial cost and all are part of the variable cost of a plant system controller. So option A is correct. And both incremental cost and marginal cost represent the rate of change of cost with respect to a given base variable. However, the marginal cost depends on operating point, while the incremental cost is defined for a specific increment. So this is also correct. Right. So which one of the following is are correct about the deterministic meta-heuristic optimization techniques? Meta-heuristic techniques are better suited for multi-objective optimization problems due to their ability to explore a larger solution space, while deterministic techniques struggle with the higher dimension problems. Whereas in the option B, deterministic techniques are more effective in higher dimensional solution space as meta-heuristic techniques suffer from the cost of dimensionality. So option C, both meta-heuristic and deterministic techniques face challenges in handling high-dimensional problems with no clear advantage for either of the approaches. And the last one, both heuristic and deterministic techniques converge at the same rate with no significant difference in their convergence behavior. So, from the lecture itself, we can clearly understand that it is suited for multi-objective problem, explore larger solution space. Deterministic methods struggle with hyperdimensional. So option A is correct. So with our next question, this is also a MSQ question. Which of the following characteristics encourage the use of evolutionary algorithms for the optimization of distribution system planning problems? So, evolutionary algorithms can effectively solve multi-objective convex optimization problems for distribution system planning. However, they are not able to tackle non-convexity. Evolutionary algorithms can handle non-linear, non-convex, non-differentiable problems effectively, do not suffer from the curse of dimensionality. So directly we can observe that option B is correct because in the lecture itself has directly mentioned that they can be directly solved and the evolutionary algorithms do not suffer from the curse of dimensionality. Next, coming to evolutionary algorithms can provide a set of Pareto approximated solutions and multi-point search in a single run. So this is also correct. Okay, okay let's do one or two questions more, which so which one of the following is not uh, heuristic based optimization? So it's vendors competition. So what are the key characteristics that make a dynamic programming suitable approach for distribution system planning? So here option is overlapping subproblems and optimal substructure. This is how is the position vector based on velocity? How is the position vector updated based on velocity vector in PSO particles form optimization? Position is randomly reassigned at each iteration. Position is updated using a constant velocity value. Position is adjusted based on velocity and time step. Position is not updated based on velocity but only based on global best position. So, so you can clearly see C is the correct answer. Position is updated based on velocity and time step as well. Okay. So that's it from my side today. So if you have any queries, you can ask. Otherwise, we can end today's session and we'll join next next Tuesday. Okay then. Let's